Welcome back, student. In this video, we are going to solve some MCQs from coordinate geometry. So the first question is, the triangle whose vertices are 0, 0, 2.7, 0 and 0, 4.9 is an equilateral triangle, right angle, an obtuse angle triangle, right angle triangle, obtuse angle triangle, and isosceles triangle. Which one of them is correct? So let's plot these given points in a 2D plane. So the first point is 0, 0, that is, it is nothing but the origin here. Origin, let me change the color. Origin. And the next one is 2.7, 0. 2.7, suppose this is 1, this is 2, this is 3. 2.7 will be somewhere in this place. Let me write somewhere there. 2.7, this is just assuming it is not an accurate graph. And 0.4.7, 1, 2, 3, 4, and 4.9 it is actually 1, 2, 3, 4. 4.9 will be somewhere here. And if we connect all the points, it will be like this. And when we have connected all the points, then we have got a triangle, and this is nothing but a right angled triangle. So the option is right angled triangle. Option B is the correct answer. So let's move on to the next question. If P is a point whose coordinates is given as a by 3, 4 is the midpoint of a line segment joining the points Q and R, and coordinate of Q is given as -6, 5, and coordinate of R is given -2, 3. So let's write these coordinates first. Q -6, 5, 5, and R is given as -2, 3. These are the coordinates of the points Q and R. And we have the formula for the midpoint of 2 points. Suppose we are finding the midpoint of Q and R, and here given that P is the midpoint of the line segment joining these 2 points. So if we find the midpoint Q and R as Q and R, it will be like we have a formula: x1 plus x2 divided by 2 and y1 plus y2 divided by 2, and x1 plus x2 will become -6 minus 2. This is actually plus -2 divided by 2, y1 plus y2 5 plus 3 divided by 2, and it is -6, -2 divided by 2, and this will be 8 divided by 2, and here we can say that this is nothing but -8 divided by 2, and this is 8 by 2, so we can get it as -4, 4. We have the formula for the midpoint of the point. Suppose the point is Q and R. So the midpoint of QR is found out as this point, and this must be equating with the given point, this point P. So if we equate them, so equating, we get A divided by 3 is equal to -4, and on simplifying this equation we can get A as equal to -4 into 3, and it is nothing but -12. Is there any option like -12? A is equal to -12. The value of A is here -12, so this is the answer. That's all for this question. Let's move on to the next question. And the question is, the distance between the points AB, coordinates of the points is given as a, b, and -a, -b. We have to find the distance between these two, and we have the formula for distance between 2 points. Suppose P is given as x, y, and Q is given as x2, y2. Let's make this x1 and this y1. So if we find the distance between these 2 points, then we can have a formula like PQ is equal to, within square root, x1 minus x2 whole square plus y1 minus y2 whole square. And sometimes you can see that x2 minus x1 and y2 minus y1, when we'll square this quantity, then you'll get the same things, because if you can get only sometimes a negative quantity by reversing this order, by changing this order. So square of a negative quantity will again become a positive quantity, so that things doesn't matter actually at all. And now we have the points P and Q as AB and minus A minus B. So we'll put this as A minus A will become A plus A whole square, and plus B minus B will become B whole square. So it will become 2A whole square plus 2B whole square. So you can get it as 4A square plus 4B square. So it will be square root of 4A square plus B square. Out of the square root will become square root of 4 will become 2. One gets out of the square root, and the remaining thing will be A square plus B square within square root. So this is the answer actually. So is there any option like this? Yes, this is the answer. This is for this question. Let's move on to the next question. The point xy is equidistant from these 2 points. Okay, the points whose coordinate is xy is equidistant from these 2 points. Okay, we have to find a linear relation so that we can get this type of equation as the answer. Linear relation or equidistant. Let's name this point as P, this as suppose A, and this as B. Now since P is equidistant from A and B, so P is equidistant from A and B. If P is equidistant, then therefore AP must be equal to BP. And let's find AP now. AP. Okay, distance. Using distance formula, we can find AP as x minus 7 whole square plus y minus 1 whole square, and it will be equal to BP. So let's find the distance between BP. So it will be x minus 3 whole square plus y minus 5 whole square, and squaring both sides so we can get them as without square root, so square root will get removed. So we will be left with x square minus 2ab minus b square, so it will be x squared minus 14x plus 49 plus y square minus 2y plus 1, and this part will be equal to x squared minus 6x plus 9 plus y square minus 10y plus 25. X square and x square will cancel each other, so we will be left with minus 14x plus 6x minus 10y will be plus actually, minus 2y is equal to, we'll get 25, and 25 when added to 9 will become 34 minus 49 plus 1 will be 50. So the linear relation, we will get it as minus 8. These two will become minus 8x, and 10y minus 2y will be 8y is equal to minus 16, and dividing by 8 we get minus x plus y is equal to minus 2, and multiplying the equation by minus 1 we can get it as x minus y is equal to 2. So x minus y is equal to 2 is the answer. X minus y is equal to 2, C is the answer. That's all for this question. Let's move forward. The distance between the point P and x-axis, this is quite critical question. For this type of question, what will be the coordinate of x-axis? This is the actual funda. Suppose P is a point, let's plot it in the graph. 2, 3, 4, 2, 3, 2 and 3. This will be the point P. And now we will find the shortest distance between P and x-axis. And here it was told that, or the question asks, the distance between the point P and x-axis, that is P, distance between P and x-axis. So x-axis coordinates, we will consider, or we will assume the coordinate of x-axis at this point, because if we connect these two, this will be the shortest distance between point P and x-axis. So the coordinate of this point will be 2, 0. So assuming 2, 0 as the coordinates of x-axis for this purpose, we will find the distance between P and x. So it will be, suppose considering this point as x, capital X, so it will be Px is equal to 2 minus 2 whole square. This is 2, 3. So 2 minus 2 whole square and 3 minus 0 whole square plus 3 minus 0 whole square. So it will be 0 square plus 3 square. It will be root 9 and it will be 3. So answer is 3. Let's move on to the next question. The distance of the point P from the origin. Suppose point minus 6 and 8 is somewhere. Minus 6, 1, 2, 3, 4, 5, 6. This is minus 6 and 8 somewhere will be there. So if this is the point, so I'm assuming this as this is the point P, and origin will be here. So coordinate of origin we know as 0, 0. So we'll find the distance between these 2 points, origin O. So PO will be 0 minus 0 plus 6 whole square plus 0 minus 8 whole square. So it will be 6 square plus 8 square minus 8 square. It will be 36 plus 64. So it will be square root of 100 and it is nothing but 10. So 10 is the answer. Let me tell you one more thing. Whenever we are finding the distance of any point from origin, then we can do straight away that, suppose this is the point, so we can find it as P0 is equal to minus 6 square plus 8 square, and it will again be square root of 36 plus 64, and you will get it as 10. You can straight away use this formula, suppose, and the formula will be x squared plus y square within square root, for such purpose in which you are to find the distance between a point and the origin of plane. Now the question is, the perimeter of a triangle whose vertices are 0, 4, 0, 0, 3, 0 is, so perimeter of a triangle means the sum of all the sides of the triangle. So to find this side, so we'll first find the sum of all the sides, and then we will find the perimeter of that triangle. So if we find the distance between any two, then we will get one side, and again we will find the distance between these two, we'll get another side, and if we find the distance between these 2 points, we'll get the third side, and this way we can find the sum of all the sides, and then we'll add them together. So without making it lengthy, I am considering this as point A, and this B, and this as C. Suppose these are 3 points given to us, and we have to find the distance between AV. So we will find the distance between AV, and we will add this to BC, and then we will add this to SC. So let's find the distance between them. So AB distance will be 0 minus 0, 0 minus 0 whole square plus 4 minus 0 whole square plus, for BC we'll get 0 minus 3 whole square plus 0 minus 0 whole square. So let's write 0 minus 3 whole square plus 0 minus 0 whole square, and we'll add that to the distance between A and C. So A and C will be 0 minus 3 whole square plus 4 minus 0 whole square. So let's add them all. So this will be 0 minus 0 whole square will be 0 plus 4 minus 0 whole square, that is 4 square is 16, plus this will be 3 minus 0 will be minus 3 minus 3 square of minus 3 will be 9, plus this will be 0 plus 0 minus 3 will be minus 3 and minus 3 square will be 9, plus 4 minus 0 will be 4 and 4 square will be 16. So we can get them as square root of 16 plus square root of 9 plus square root of 25, and we can get them as 4 plus 3 plus 5, and 4 plus 3 plus 5 will be 12. And 12, is there any option? Yes, C is the correct option. So that's all for this question. Let's move on to the next question. The area of a triangle whose vertices are 3, 0, 7, 0 and 8, 4 is 6, 8, 14 or 28. Let's first name the vertices as this is our A, this is B. We are now finding the area of the triangle ABC whose vertices are given accordingly. And we have a formula for finding area, unlike the perimeter case. So the formula is area of a triangle ABC, suppose, with coordinates x1, y1, x2, y2, x3, y3. So let's write the formula. And the formula is like this is x1 of y2 minus y3, y2 minus y3 plus x2 of y3 minus y1, y3 minus y1 plus x3 of y1 minus y2. Okay, now let's put the values of the x1, x2, x3 and y1, y2, y3 accordingly. So we can get it as half of x1 is 3 of y2 minus y3. y2 is 0 and y3 is 4 plus x2. x2 is 7 and y3 minus y1. y3 is 4 minus 0 is y1 plus x3. x3 is 8 of y1 minus y2. y1 is 0 minus y2 is also 0. So that will be the value. So 3 of minus 4 plus 7 of 4 plus 8 of 0 will be 0 actually. So here we can get them as minus 12 plus 28 plus 0. So it will be half of 28 minus 12 is 16 and half of 16 is 8. So it will be 8 square unit. There is no talk of unit, so let's ignore it. Answer is 8. That's all. Let's move into the next question. ABC is a rectangle whose three vertices are A 0, 3, O origin 0, 0, B 5, 0. Let's draw a figure as suppose this is our origin and coordinates of this will be 0, 0 and B is given as 5, 0. So it will be here some B is equal to 5, 0 and another vertex is given as A. Suppose A, this is A and coordinate is 0, 3. So this is a rectangle and this will be our C, and we have to find the coordinate of this. Actually we don't need to find the coordinate of this, we are to find the length of its diagonal. So here we can see that diagonal of this rectangle can be found as the distance between A and B. If you find the distance between these two, then we have got the diagonal of this rectangle. Since coordinate of A and B are given to us, so we can find it easily. So let's find the distance between A and V. So AB will be 5 minus 0 whole square plus 0 minus 3 whole square. So it will be 5 square plus minus 3 whole square. So it will be 25 plus 9, and it is nothing but square root of 34. So square root of 34 is given as an option. So this is the answer. Let's move on to the next question. And the question is, if the point P, whose coordinate is 2, 1, lie on the line segment joining the points AB, both are given with their coordinates. So we'll find AB first. Let's find it, and then I'll tell you what to do. This will be AB will be 8 minus 4 whole square plus 4 minus 2 whole square, and it is nothing but 4 square plus 2 square. So it will be square root of 16 plus 4 and square root of 20. And now it is said that P is a line on the line segment joining A and B. Suppose this is the line AB and P is point somewhere in this distance, in between A and B. So we will find the distance between AP and BP also. So let's find AP will be equal to 4 minus 2 whole square and 2 minus 1 whole square. 2 minus 1 whole square. It will be 2 square plus 1 square will be square root of 5. And now let's find BP also. BP will be 8 minus 2 whole square plus 4 minus 1 whole square. So it will be 36. 6 square will be 36 plus 4 minus 1 is 3 and 3's square will be 9. So it will be square root of 36 plus 9 is 45. Square root of 45. And now the question here is, which of the relations is valid? So let's check the relationship. First one, we'll check for the first one, which of them is valid. Let's check the first one. AP is equal to 1 by 3 of AB. We have found all the values AP, AB and BP. Here you can see that again and again these values are attached with the relations. So AP is equal to AB can also be written as AP by AB is equal to 1 by 3. If we move these to the left hand side, then we'll get it as AP divided by AB is equal to 1 by 3. And now
if we find the ratio of these distances,
is it equal to 1 by 3? If yes, then the relation is valid. Otherwise, this is not the answer for us. So let's find AP divided by AP is found out as root 5, square root of 5, and AB is found as square root of 20. Now square root of 20 can be written as, let's factorize square root of 20. Let's find the square root of 20. Square root of 20, it will be 2 tens are 20 and 2 5s are 10. So here we will take 1 2 from these two, and it will be 2 root 5, and here will be root 5, and root 5 will get cancelled. So this value will be 1 by 2. And now if we equate this to this value, AP is equal to AV, it is not equal to 1 by 3. So this is not the case, so it will not be the answer for us. Let's move on to the next question. AP is equal to PB. Here we can clearly see that AP is equal to root 5 and PB or BP is equal to square root of 45. Both are not equal, so this will again not our answer. Let's check for the next one. PB is equal to, this BP is equal to 1 by 3 of AB. So let's go for it. BP, we can write this equation as BP divided by AB is equal to 1 by 3, and we have seen that the value of BP is square root of 45 and the value of AB as square root of 20. And if we find these values, square root of 45, suppose let's find it. 45, 3 15s are 45 and 3 5s are 15. So 3 root 5 is nothing but 3 root 5 is nothing but square root of 45, and square root of 20, as we have found earlier, it is nothing but 2 root 5. So root 5 will get cancelled, so it will be 3 by 2, which is not equal to this 1 by 3, so it will not again be the answer. So the remaining case will be the answer. So let's verify this. AP divided by AB is nothing but half. And if you have observed that in the first case, AP divided by AB was given equal to 1 by 3, but we found it as 1 by 2 here. So this is correct option. So this will be the answer. This relation is valid for the given conditions. So that's all for this video.